All right, Toby, we are live.
Excellent. Okay. If you're tuning in over here at Ether Cosmology or over at Space Audits, or if you are on one of the Anti-Disinfo League platforms, thank you so much for listening. Tonight, we are going to do some reading. If you're not familiar with what we do over here on Ether Cosmology on Thursday nights, we do reading and research nights. And we don't necessarily do this for, for entertainment for you necessarily. We don't put together presentations for Thursday nights or anything like that. What we do is get into an actual paper or an actual book or something along those lines, and we do actual live research where we ask each other questions or we just read through the papers. And so tonight we're going to be reading a paper about special relativity and the implications of Ruyang Wang's experimentation. And this paper is called Circular and Rectilinear Sagnac Effects Are Dynamically Equivalent and Contradictory to Special Relativity Theory. So I'm going to go ahead and share my screen here so we can get started with reading. And thank you so much, everybody, for tuning in. Before we get started, anyone have any quick little comments, thoughts, concerns, questions? Cool. I'll go ahead and start it off then. So we've got circular and rectilinear Sagnac effects are dynamically equivalent and contradictory to special relativity theory by Ramzi Suleiman from the Triangle Center for Research and Development in Israel. Pardon me. So the abstract. This is from apparently was received in 2016, published in 2018. So abstract. The Sagnac effect, named for its observer, is the phase shift occurring between two beams of light, traveling in opposite directions along a closed path around a moving object. A special case is the circular Sagnac effect, known for its crucial role in the GPS system and fiber optic gyroscopes. It is often claimed that the circular Sagnac effect does not contradict special relativity theory because it is considered an accelerated motion, while special relativity theory applies to only uniform, not accelerated motion. But, a quick side note, we all know there are, still papers that have to explain it with Lorentz transformations that are very difficult to understand physically and not very meaningful. So, anyways, or I would argue not very meaningful.
Well,
It is further.
they don't
Go ahead.
provide a physically meaningful explanation, rather, right? Like they
Yep.
explain it with a Lorentz transform, but they can't explain the fringe difference. But we'll keep going.
Yeah. So it is further claimed that the Sagnac effect manifest in circular motion should be treated in the framework of general relativity theory. We counter these arguments by underscoring the fact that the dynamics of rectilinear and circular types of motion are completely equivalent, and that this equivalence holds true for both non-accelerated and accelerated motion. With respect to the Sagnac effect, this equivalence means that a uniform circular motion with constant W is completely equivalent to a uniform rectilinear motion with constant V. We support this conclusion by convincing experimental findings, including that an identical Sagnac effect to the one found in circular motion exists in rectilinear uniform motion. We conclude that the circular Sagnac effect is fully explainable in the framework of inertial systems, and that the circular Sagnac effect contradicts special relativity theory and calls for its refutation. Introduction. The Sagnac effect is a phase shift observed between two beams of light traveling in opposite directions along the same closed path around a moving object. Called after its discoverer in 1913, the Sagnac effect has been replicated in many experiments. The circular Sagnac effect is a special case of the general Sagnac effect, which has crucial applications in fiber optic gyroscopes and inertial navigation systems, such as the global positioning system. The amount of the circular Sagnac effect is calculated in a Galilean summation of the velocity of light and the velocity of the rotating frame, c plus or minus rotation, or what is this, omega, right?
Yep.
Omega times r. The difference in the time intervals of two light beams sent clockwise and counterclockwise around a closed path on a rotating circular disk is delta t equals 2vl over c squared, where v is omega r or where v equals omega r is the speed of the circular motion, and L equals 2 pi r is the circumference of the circle. In fact, the Galilean summation of c and plus or minus wr contradicts special relativity theory's second axiom and the Lorentz transformations. Go ahead and just give that a quick little highlight.
You can't do Galilean velocity addition with the speed of light. That was disproven by Michelson-Morley.
That was disproven when we found out the Earth wasn't moving. Nonetheless, it is consensual that the Sagnac effect does not falsify special relativity theory because it is manifested in circular motion, which is considered an accelerated motion, while special relativity theory applies only to inertial, non-accelerated systems. Based on this consensus in the GPS, concurrent corrections for the Sagnac effect and special relativity theory's time dilation are made. Moreover, some theoreticians claim that the Sagnac effect manifests in circular motion should be treated in the framework of general relativity theory and not special relativity theory. I wonder what those citations are. I want to take a quick peek at that. Just kind of curious.
I'm going to see what those theoreticians claim. Was it 16 and 17?
That was numbers 16 and 17.
Yep.
Ashtakar and Magnan, and then Vigier. I'll just drop these in the chat real quick. All right.
Yeah, can you highlight those so when we come back for citations at the end, we can have a collection of what we thought was interesting to come back to. Put a little note on them.
The view that the Sagnac effect is a property of rotational systems is strongly disproved by Wang and his colleagues, citations 8 through 20, who conducted experiments demonstrating that an identical Sagnac effect to the one found in circular motion exists in rectilinear motion or rectilinear uniform motion. Using an optical fiber conveyor, the authors measured the time travel difference between two counter-propagating light beams in a uniformly moving fiber. Actually change to... Their finding revealed that the travel time difference in a fiber segment with length delta L moving at a speed v was equal to delta t equals 2 times the velocity delta L or delta length over c squared, where the segment was moving uniformly in rectilinear or circular motion. The existence of a Sagnac effect in rectilinear uniform motion is at odds with the prediction of special relativity theory and with the Lorentz invariance principle, and thus should qualify as a strong refutation of both theories. Just one moment. I'm going to grab a drink of water here.
Yeah, while you're doing that, I have to reset my internet. It did not go well when I went live.
Oh, no. Okay.
Yeah,
So we need to take a quick
take
little
like a quick fiber. Sorry about that.
quick little intermission here. All right. So, this is my weakness. This is where I start making really dumb jokes.
What's everyone's favorite color, guys?
Don't remind
get up on stage. Oh my god.
Don't remind me.
Living color.
Oh no, me and Stone are gonna be the worst combo on this.
It's gonna be like dad joke after dad joke.
No, that's a tune by Living Color. What's your favorite color?
Oh,
Living Color. Yeah, it's a great tune.
We need some more Stone tunes. How do we get fed some Stone tunes?
yeah, we do need some more Stone tunes.
You need some stuff, eh? You guys want to hear?
Make sure everything's live.
Yeah, they're all listening to an Allison Chains tune. It's up in the chat.
Respect.
We do need some more. Yeah, I just clicked off now. We are now back from intermission. We listened to about 20 seconds of the Allison Chains intro, just enough to get us copyright striked.
Nice.
East.
That's the proper amount.
Thank you,
Alright.
everybody, for bearing with us while we deal with our internet technical issues. Shout out to the viewers on YouTube, Twitch. Actually, I don't think there's any viewers on Twitch, but the viewers on YouTube, no longer on the ball, Television, whoever else is out there listening. Thank you for being here with us. Yeah, so back to reading time, huh?
Yep. Yes, sir. Yeah, cool. It looks like it preserved the stream or whatever, like it didn't time out, so I don't even have to make new streams.
Oh, fantastic.
My favorite. All right, let's roll.
So we were right around here, right? The existence of a Sagnac effect in rectilinear uniform motion is at odds with the prediction of special relativity theory and with the Lorentz invariance principle, and thus should qualify as a strong refutation of both theories. However, despite the fact that Wang and his colleagues published their findings in well-respected mainstream journals, their falsification of special relativity theory's second axiom and the Lorentz transformations has been completely ignored. To the best of my knowledge, no effort was done by special relativity theory experimentalists to replicate Wang et al.'s falsifying test of special relativity theory. Ooh, that's definitely getting a
Is
nice
there
big
such a
red
thing?
highlight.
Is there such a thing as an experimentalist with relativity? Who's testing it and how?
Well, they say they do experimentation, but then they run it all through simulations. They kind of have that false premise of where's my yeah.
Well, we know C equals C, so our experiment must have been faulty. We'll just add a little correction coefficient in there, see if we can't make C plus or minus V equals C on the way out.
Sounds like it's covered in wanker sauce, but let's move on.
In this short note, we provide strong theoretical support to the aforementioned findings regarding the identity between the rectilinear and circular Sagnac effects by underscoring the fact that, in disagreement with the acceptable Newton's definition of inertial motion, the dynamics of rectilinear and circular types of motion are completely equivalent, and that this equivalence holds true for both accelerated or non-accelerated and accelerated motion.
Oh no.
Those line numbers are kind of annoying. We elucidate this fact in section 2 and in section 3. We draw conclusions regarding the contradiction between rectilinear and circular Sagnac effects and the predictions of special relativity theory. Whoa. My bad. Change. Wait, what?
You're
I
good.
missed the bottom here. My bad.
Yeah, you did. Oops.
We're right here. On the equivalence between circular and rectilinear kinematics. The common view in physics is that the above mentioned two types of motion are, in general, qualitatively different. Linear motion with constant velocity is considered inertial, while circular motion, even make that pink.
Yeah, I feel like this is about to become an infograph, actually.
While circular motion, even with constant radial velocity,
Did someone say infographic?
Yeah. Yeah, we're about to make one off of this. Well, for this paper we're
Ruth's
reading.
here. Oh, hey, Ruth.
are you going to start helping us
Yeah.
show the ineptness of special relativity theory, Ruhiv?
Through memes or
No,
infographs?
yeah, memes.
No, we can't. He doesn't know how to memes. Infographics. Yeah, he'll help.
Infographics. All right, back on mute.
So while circular motion, even with constant radial velocity, is considered an accelerated non-inertial motion. So linear motion is considered inertial, while circular motion, even with a constant velocity, is considered accelerated, or an accelerated non-inertial motion. So let's go ahead and also highlight that. It's a good point.
Yeah, because that
The above
was that's how they made that's how they got people to accept that the Sagnac, what Sagnac measured wasn't a violation of special relativity, and then they're like, "Well, we gotta put it in general relativity because it's an acceleration, so we have to treat it through that, we have to give it that mathematical treatment instead." So this is a huge distinction because of the inertial frame, right? If you're in an inertial frame, C must equal C. It can't be anything else. Continue.
Yes, sir. Well said. The above view is not restricted to the Sagnac effect or to relativistic motion, but is believed to be a general distinction in classical mechanics as well, and is repeated in all books on physics. This common view maintains that the centripetal force acting on a rigid rotating mass causes continual change in its velocity vector, reflected in the change in its direction, keeping it in a tangential direction to the circular path. Here, we challenge this convention by claiming that there is a one-to-one correspondence between linear and circular types of motion. In the language of systems analysis, the two types of motion are completely equivalent systems. The proof for our claim is trivial. To verify that, consider a dynamical system of any type, physical, biological, social, etc., which could be completely defined by a set of dynamical parameters. Pi, I equals 1 iterating to 6, and a set of equations are defined as equation 1 here. If we think of the P series as representing rectilinear position X, velocity V, and acceleration A, respectively, and of P4 through 7 as mass M, rectilinear force F, work W, and kinetic energy E, respectively, then the dynamical system defined by R gives a full description of a classical rectilinear motion. See Table 1. Table 1.
Oh yeah, scroll down, check this out. So we got the equations right next to each other, and what you're gonna start to realize is that they're oddly just the same. They're describing the same thing with a different variable to describe the type of motion.
Yeah, it's so like
Well, that's
so
peculiar.
straightforward, right? Peculiar, yeah. All right. So, back up. So table 1, which we just looked at. Alternatively, if we think of P1 through 3 as representing angular or representing angular position 0, velocity W,
Theta.
and acceleration position theta, velocity W, and acceleration what is this one?
Alpha.
I would call that alpha.
Okay. Kind of crazy looking. Respect and acceleration alpha, respectively, and of P4 through 7 as radial inertial I, torque. What is this?
Tau.
Oh,
All right. I'll do my freaking
That's
homework.
You haven't studied your Greek alphabet, bro? Like, what's up?
Dude, I know. This is freaking embarrassing. We've read so many of these papers now, too, and I'm still doing it. All right, work W and kinetic energy E, respectively. Then the dynamical system defined as R gives a full description of a classical circular motion, quantum electrodynamics. Right? Isn't that what QED is meaning there?
What I would assume.
big score.
It is worth noting. What's that?
He scored big there.
It is
Yeah,
worth.
big score.
Okay. It is worth noting that the equivalence between rectilinear and circular dynamical systems is not restricted to the special case of rotation with constant angular velocity or even with constant acceleration.
Can you highlight
We
that?
note here that the equivalence demonstrated above between the dynamics of uniform rectilinear and uniform circular types of motion is inconsistent with Newton's first law, which states that unless acted upon by a net unbalanced force, an object will remain at rest or move uniformly forward in a straight line. According to this definition of inertial motion, which was adopted by Einstein, a circular motion with a uniform radial velocity is considered an accelerated motion. However, the above demonstrated equivalence is at odds with Newton and Einstein's views of inertial systems. It is, in fact, based on Newton's mechanics, the first law for circular circular motion could be derived simply by replacing in the original statement of the law the words straight line by the word circle, thus yielding the following law. A body in circular motion will continue its rotation in the same direction as at a constant angular velocity unless disturbed. Quite interestingly, our view of what defines an inertial yeah, I'm like highlight that.
Yeah, did we just add a new law there to the old new?
I don't
Yeah,
know.
it's
I don't see
interesting.
that quite as synonymous. I think there's a qualifier that's
Yeah,
missing.
let's see what he says about it here. What point he's making. Quite interestingly, our view of what defines an inertial system is in complete agreement with Galileo's interpretation of inertia. In Galileo's words, all external impediments removed, a heavy body on a spherical surface concentric with the Earth will remain itself in that state in which it has been. If placed in movement toward the west, for example, it will maintain itself in that movement. Okay. This notion, which is termed circular inertia or horizontal circular inertia. Jeez, oh, Pete's, man. Horizontal circular inertia. That old horizontal circular inertia. By historians of science, is a precursor to Newton's notion of rectilinear inertia. A deeper inquiry of the different opinions of the notion of inertia throughout the history of physics is beyond the scope and aims of the present paper. Nonetheless, we dare to put forward the following definition of an inertial motion, which agrees well with Galileo's conception. According to the proposed definition, a rigid body is said to be in a state of inertial motion if and only if the scalar product between the sum of all the forces acting on the body and its velocity vector is always equal to zero. Or equation 2 here. Note that the condition in equation 2 is satisfied uh, under ideal conditions only by two types of motion, the rectilinear and circular types of motion. Although it is not so, conclusions and general remarks.
It's just pointing towards centripetal balance, I think, without actually saying it.
Hmm. Although it is not the subject of the present paper, our demonstration of the complete equivalence between circular and rectilinear dynamics based on Newtonian dynamics calls for a reformulation of Newton's first law, which is in line with Galileo's view of inertial motion. Such reformulation is far from being semantic. Huh, yeah, you don't say. You don't say that something that utterly refutes special relativity is not being semantic. Get a good highlight here. Boom. By accepting the fact that the circular and rectilinear dynamics are completely equivalent, it becomes inevitable but to conclude that the Sagnac effect in uniform circular motion is completely equivalent to the Sagnac effect in uniform rectilinear motion, and that both effects contradict special relativity theory. Moreover, the claim that the circular Sagnac effect should be treated in the framework of general relativity theory simply does not make sense. In most Sagnac experiments, the experimental apparatus is of small physical dimensions. Yes, 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 yes. It's not relation to the sun, allowing us to assume the gravitational field in the apparatus is uniform, thus excluding some general relativity effects. Like seriously, who do they think they are getting all like what?
Dude, bro, they came up with the math to describe, its rotation, but the energy would be proportional to a gravitational field that would do a little bit of link contraction and time dilation in accordance with that velocity to produce the effect. Like they literally just put the Sagnac effect in relativity or in GR with that. You're like, here you go.
That's so insane. How is it any better?
It's just because it
Oh,
gives them
man.
like a physical explanation along with the math, and they're like, "Oh, dude, on the smallest level, look at this locally rotating device. It's proof that there's a divergent temporal time pocket between
Oh, look,
an inertial observer at the
general
center of the
relativity
device."
proof, right where we were looking for it.
Yeah. Yep.
Another erroneous justification for the coexistence between special relativity theory and the Sagnac effect is that the observed effect could be derived from special relativity theory by using Lorentz transformation expressed in coordinates of a rotating frame. This claim is based on fact that the difference between the detected effect and the one predicted by special relativity theory amounts to 1/2 v over c squared, which is or 1/2 times v over c squared, which is claimed to be negligible for all practical cases. So I guess in applications. We argue that this line of reasoning is erroneous in more than one aspect. The directionality of the Sagnac effect is dependent on the direction of light travel with respect to the rotating object, whereas the time dilation effect is dependent on the direction of the motion.
Oh, wow. That's a interesting way. Interesting thing to point out.
The directionality of the Sagnac effect is dependent on the direction of the light travel with respect to the rotating object, whereas the time dilation effect is independent of the direction of motion. Yeah, that is a pretty interesting thing to point out. The directionality of the Sagnac effect is dependent on the direction of the time. Special relativity is founded on the axiom postulating that the motion of the source of light relative to the detector has no effect on the measured velocity of light. Whereas in the Sagnac effect, the Galilean kinematic conception of velocity, c plus v or c minus v, is the reason behind its appearance. Uh, At relativistic velocities, for which special relativity theory predictions become practically relevant, the second order of v over c can amount to values approaching 1. And reference 4, the aforementioned, or equation 4, the aforementioned difference, even if infinitesimally small, as in the case of GPS, could not be overlooked because it is a systematic deviation between the model's prediction and reality, and not some kind of statistical or systems error. Hmm. I got a feeling someone here has a thought about that.
Well, let's just say some of these relativistic effects cancel each other out, and we just account for your boy, the old Sagnac effect, the old first order velocity component.
Finally, we note that the abundance of experimental findings in support of special relativity theory, mainly its prediction of time dilation, is no more than what Karl Popper calls confirmation tests out of the theory. What is needed is to subject special relativity theory to stringent tests, i.e., to what Karl Popper has termed a risky or severe falsification test.
A risky
Oh,
prediction.
someone looking for some risky predictions?
We might want to get real.
Oh, we got some risky predictions for
Dude,
you.
forcing a
Shout out Ruyang
relativist to make
Wong.
a risky prediction is one of the hardest things you'll ever do.
Shout out Ruyang Wong 2017, 2016, whenever that was. I think 2016. That paper poses exactly this. Evidently, the Sagnac effect arising in rectilinear and in circular motion qualifies as well, yeah, I would say that as well. It literally was put to the test back in the 1800s with a frickin' Fresnel drag. And then again in 1913 by Sagnac, and then again in 2004 by Ruyang Wang. But in any case, such experiments have already been performed in linear and circular motion by Wang and his colleagues. And we have shown here that the two types of motion are completely equivalent. You sure have. And you're not the only ones. We have no other way to conclude that the physics community is acting irrationally and unscientifically. A good paper. It's just straight. I mean, like, I don't mean that, like, I know it sounds biased for me to say that, but like, what else do you even, there's no other way to put it, in my opinion. Like, they're literally acting irrationally and unscientifically. They just like hand wave dismiss this.
Lost in the math, bro.
Yeah, it's a good way to put it.
Then you get
The logic
overeducated,
behind
and it's like, how could anyone be right if you're all mathed out? You know?
Yeah.
Like, look at
The
this.
logic behind
Sorry, go ahead. Now we're good.
okay. The logic behind the second axiom of special relativity theory is shaky, and Herbert Dingle's argument, citations 36 through 38, that it leads to contradiction has never been answered without violating the principle of relativity itself. On the experimental side, the Sagnac effect detected in linear motion is a clear falsification of the theory, and we have closed the loophole by showing here that what applies to rectilinear motion applies to circular motion.
Hey, will you highlight those citations real quick, 36 and 38?
Yeah.
Want to see what Herbert's argument was, because there's a couple of arguments that went completely unrefuted by Einstein that just are devastating. I'd like to get a nice collection of those going.
$36 and $37.
Thank you, sir.
No problem. So yeah. In science, it takes one well-designed and replicated experiment to falsify a theory. As put most succinctly by Einstein himself, if an experiment agrees with a theory, it means perhaps for the latter. But if it does not agree, it means no. Yeah, I'm going to get that highlighted too. Because everyone loves, you know how some people love listening to Mr. Einstein. Well, there you go. Mr. Einstein says that Wang.
Quote mining or whatever, you think? You think he read all Einstein's text just to get that part?
Dude, yeah, because I'm sure in context what he's actually saying here is that special relativity has to be true no matter what. Right?
Yeah.
That's what Einstein meant by that.
I think so.
Yeah, must be. All right. Anyways, meanwhile, an experiment falsifying special relativity theory is flying above our head in the GPS and similar systems, but there are no good and brave experimentalists to observe them and observe the results. Well, there's not that many. Shout out wrong. We are not aware of a similar case in the history of modern science, where a theory which defies reason and conscience. right. This has to get a good color. Let's see here. We'll do dark yellow. No, we need red. We are not aware of a similar case in the history of modern science where a theory which defies reason and contradicts with the findings of crucial tests.
Oh, hold on. Yo, Bennett's here. Yeah.
Oh.
Yeah, what's up, Bennett?
Perfect.
Your mic's going hot though, and it sounds like you're in a car or something, so we had to mute you for a second. We're gonna unmute and see if it's better. Nope. There's definitely Hold on one second. There's an ambulance.
We missed you, Robert.
Pull over.
Yo, there it is. Got you unmuted now.
What's up, guys?
Hey, what's up, man? How you been?
All right. I forgot about this Thursday night meeting, so I just tuned in.
Yeah, you're late. What the heck, Robert?
Good to see you.
I can always see the replay.
That's good.
Nice.
It's good to see you back. We missed you.
Yeah, I
Yeah.
saw you were doing Sagnac, right?
Yeah, talking a little Sagnac tonight.
Uh-huh. Yeah, I saw the lock horns you had with that Matt from Science Facts.
Oh yeah, I can science that. Yeah,
You and Toby had a little mix up with them.
Mm-hmm.
yeah, a little relativistic mix match, you could say, or whatever, mix match.
Yeah, so I'm probably gonna look at that now that I got some time to look at some of the videos that he posted about the Sagnac. No, it was the Wang.
Yeah,
Yeah.
the Wang
Yeah, it was
experiment. He was trying,
the Wang test.
trying to explain it as a relativistic effect. Some say he's still out there trying to derive it.
Yeah, well, he made some statements that are, just on the face of it,
Retarded.
easily disprovable.
Yeah,
And maybe I'll put something together and write it up. And if you want to do a video sometime on that or anything else, let me know.
yeah, absolutely.
Nice.
Could
And
definitely
I'm
do that.
hoping that Alan looks into the farce that quantum electrodynamics is. It's claimed to be the most precise science that physics has ever produced, and yet it's full of subtraction of the infinities and coming up with a constant. Anyway, it's an interesting topic, and it's certainly worthy of being published if we can come up with a logical response to the quantum electrodynamics that's done today.
Oh yeah, I'm definitely gonna follow up on that stuff you sent me for the renormalization and the Feynman diagram that no one can ever solve except for Feynman. That's so funny.
Look at the video, Alan. It's got a list of all of the attempts to get the constant right. And every few years they come up with a new experimental test, and then they suddenly find out, doing theoretical calculations, that now they can predict it. So it's a series of, oh, we got it wrong, but now we've got it right. Oh, no, we don't. There's a new experiment. And this goes on for years and years. It's really a comedy.
Yeah, I can't wait to do a more in-depth history on it. I was specifically trying to focus on the Compton effect for that one, and like give an introduction into what is the quantization of the photon and the electron and all that. But yeah, I'm definitely going to follow up on it.
Yeah, the Compton effect, I'm looking into that because what's missing from that is not the relativity, which is wrong, but the use of classical physics without including ether. So if you include the ether drag that's caused by the electron, I think you can correctly predict what the Compton equation predicts, and do it with consistency with ether principles, ether drag, and you can do it with classical physics. That is, without relativity. You must use quantum physics. You must use Planck's equation. So that's another thing to look at, which I'm doing right now.
What do you think about the argument that the wavelengths haven't been measured for the so-called relativistic wavelength? That it's just inferred through the energy reading, and they just kind of set up a preferred way to describe the electron with no kinetic energy and all that. So they're kind of just imposing a favorable condition on relativity itself to give it a layup.
Are you referring to the Compton effect
Yeah.
relativistic solution?
Yeah, and well, that and just the measurement itself, right? Because they don't actually measure the wavelength. They're just kind of
Oh, yeah, well,
Yeah.
right. What you really should measure is the energy. The energy is more directly measured by the instruments than the wavelength. And as far as the history of the Compton effect is concerned, what was it, 1923, 1925, so like 100 years ago.
Yeah.
He did the experiment. He got good experimental agreement with the theory, and the theory was based on relativistic principles, not classical, non-relativistic. And what's happened since then is that basically it's been ignored because they said, okay, we solved that, let's go on. And it's difficult to get experimental data that repeats the Compton effect using modern techniques, which are more precise. And that's one of the problems in trying to come up with a better theory, is that there's not, at least I can't find good experimental data to support it. But if you have anything about a disagreement, send it to my email.
Yeah, I'll send
If you have
you.
anything.
Yeah, I'll send you the stuff on the energy reading because I thought that it was the other way around. I thought that getting the wavelength would be the more precise measurement to confirm that the energy measurement itself is even, related to that wavelength change.
Yeah,
Right?
it would be if you it would be if you set up an interferometer, because that's one of the most precise measurement devices. But usually what they do is just use a energy transfer
Yeah.
to detect the recoil energy as well as the input energy for the Compton effect.
So would it even be possible to set up an interferometer to measure that wavelength? Like,
Yeah,
get it-
I guess you could.
yeah, that's what I would want to see then, just to be sure that the energy output that they're even reading is from that.
Yeah, you got to use a laser though. It's got to be a single monochromatic beam, not not with a spread, a dispersion. So you got to use a laser, and you got to have a decent interferometer. Yeah.
Cool. Well, thanks for the feedback on that. I'll definitely adjust my argument for it.
Okay, I didn't want to interrupt you guys. I
Oh, you're good, bro.
intended to just. I wanted to hear about the relativity arguments.
Well, no,
Yeah.
you popped in at a great time. We just finished up that paper pretty much. There was one sentence left, so it was kind of a nice breaking point there. I'll read the last sentence, which is just we believe that it is due time for a serious reconsideration of special relativity theory and the Lorentz transformations. So,
Well, amen.
Right.
Amen.
Yeah, so we were gonna maybe read a couple more papers, but honestly, we're so thrilled to have you here. If there's anything that you would, any other thoughts that you have that you'd like to share with us, we'd be thrilled to hear. Not to put pressure on you.
Well, don't worry about what I missed, because, like I said, I can always look at the tape. No, I think what's interesting me is the Compton effect, because I think that Alan sent me an email in which he was working with a group that is claiming that the Compton effect, because of its good experimental agreement with theory based on relativity calculations, is confirmation of relativity. Now, first of all, a single experiment doesn't prove anything, because you can have false premises that lead to the right conclusion. One of the classic examples is if somebody says 1 equals 2, they can prove that it's true because if you take 1 equals 2 and add 2 equals 1, same equation reversed, you get 3 equals 3, and that's correct. So does that prove that 1 equals 2 is correct? If your conclusion is correct? No. So relativity is a very slimy creature to try and pin down, because there's a lot of experiments that are right at the level of detection, the threshold of detection. And once you get in below the threshold of detection, you can't prove anything, because is the result real or is it part of the experimental error? So that's what's been my focus. I have very little free time lately, but hopefully it will get to be more as time goes on. Okay, I seem to have lost you.
No, we're
still here.
We're just listening.
No,
Oh,
you have
my-
a captive audience.
Yeah.
Yes.
My screen timed out. That's all. I don't know why don't you continue with your show and
Cool.
Uh,
Yeah. So, should we read that other special relativity paper then, Alan?
Yeah, let me see which one we got here. So which one we just do? We did the Israeli one. So now we'll move on to the Sagnac effect in GPS, absolute simultaneity and a new meaning of time. Or we could do the truth of space-time contractions and special relativity. This is a 17-pager. I think this gentleman goes over quite a few experiments, including Wang, if I'm not mistaken. Nope, doesn't go over Wang. I'm mistaken. But it did look interesting for some reason. So you pick. 17
I mean, I'm
pages
gonna-
or 5?
that was
Five,
that was
5
kind
it
of
is. All right. So here we go. Got the old stream pulled up. We got the Sagnac effect in GPS, absolute simultaneity, and a new meaning of time by Luigi Maximilian Kigula. All right. So, abstract implementations of GPS systems has allowed the understanding of important facts about the true meaning of time and simultaneity. In fact, GPS has become a fundamental source for the understanding of clock behavior and synchronization through the considerations of relativistic effects affecting it. Among these, a very important role is played by the Sagnac effect, influencing the clock readings. The correct consideration of such effect is fundamental in every synchronization process where the receiver is moving with respect to the source. In this paper, we now show that GPS demonstrates that the explanation of the Sagnac effect given by the commonly accepted version of special relativity is not correct, and the use of an alternative formation based on inertial transformations must be used. This implies the adoption of a new synchronization procedure, the renouncing of relativity of simultaneity, and a novel meaning of physical time. Introduction. The realization of GPS has made it possible to develop many different facilities, as for example, satellite navigation systems under. All right, 1 second. Sorry about that. Ambulance got me. Or
right. It's like charming to hear.
the satellite navigation system, cellular phone networks, etc. Right. So all these things that are relying on synchronized clock systems. Nevertheless, The use of such systems beyond its technological usefulness represents one of the most selective and hard tests for Einstein's theory of relativity, able to give valuable insights about the true meaning of physical time and the validity given synchronization method, or given of a synchronization method, in particular Einstein's synchronization method. All right, on the other hand, relativistic corrections themselves must be considered in order to make the GPS system correctly working, or to keep it correctly working. As known, the GPS system is composed of 24 satellites orbiting the Earth on 6 different planes, including a 55 degree with respect to the equatorial plane. Oh, inclined 55 degrees with respect to the equatorial plane. With a revolution period of 12 hours, every satellite describes a nearly circular orbit radius of r equals 4r, where r is the radius of Earth at about 3.9 kilometers a second. Each satellite is equipped with an atomic clock, 2 cesium or 2 rubidium clocks, capable of a precision of about 10 nanoseconds. In addition to the spatial layer, there is also the control layer composed of a network of control stations at different points on the Earth's surface, with a mother station placed in Colorado. Well, that's cool. Now we know the infrastructure there. Every satellite emits omnidirectional signals at 2 frequencies: f1 at 5.1 gigahertz for usual purposes, and f2 at 1.2 gigahertz for military use. In a few words, the system operates comparing the time emissions for every sorry, I just had a thought. The emissions signals of the reception time, this difference is implied, multiplied by the velocity of the signal propagation in the direction of the satellite receiver, would give their mutual distance, and then by means of the triangulation. So he was talking about the range measurement equation. So time of signal sent, time of signal received, multiplying that by the speed of light to get the distance out of it. Obviously, this method works only after the synchronization between the 2 clocks, or between GPS clocks and the clocks on Earth. This procedure is far from being obvious. 2. Another way in which GPS can give time by sending the signals containing information about the time it has been sent as measured by the satellite clock. The receiver then compares the time given by its own clock with the received time of the former or together with the signal of the transmitter. These synchronization procedures imply the introduction of different correction factors due to the propagation delays during propagation. One of the most important is the relativistic correction arising from relative motion from source and receiver, and the gravitational effects due from the sun and Earth. There are substantially 3 types of relativistic effects to be considered in a GPS system. A, the effect of the source motion, i.e., the motion of the GPS satellite receiver, the motion of the GPS satellite in their orbits, and the receiver velocity upon the clocks. B, the effect of the gravitational potential on the satellite receiver clocks. And 3, or C, numbering, when AB3.
Oh yeah, 83. Whoa.
All right. So C or 3, depending on your reference frame, the effect due to the receiver motion upon the signal reception time, or the Sagnac effect, right? So we got a velocity correction, a gravitational correction, and a mysterious Sagnac correction. Could also be a velocity correction, right? The first 2 effects can be explained. Well, actually, and then real quick, because he's probably not going to get into it, but what Paul Marmé showed in his paper in 2000 on the constancy of the speed of light was that the equations that they use to make these corrections, they're actually they're all the same. They're all identical to what you would use to correct for the Sagnac effect. So they're just there's no like special correction that they're doing for gravitation. Like, oh, this one's different. Like, no, they're just correcting oscillation rates proportional to velocity. in situations where they shouldn't have to. That's all it is. Let's see, where were we at here? The first two can be explained with Einstein's special theory of relativity, although most parts of these official explanations are flawed and can be seriously reconsidered, given in citation 2. But the Sagnac effect has been proved to be in conflict with special relativity. A lot of explanation has been proposed in order to trace back the effect to the commonly accepted framework of relativistic physics without success. Shout out to citation 2. We're definitely going to have to figure out what that is. All right. Let's see. It has been shown that in order to correctly explain the effects, the effect introducing necessary corrections for GPS, the postulates of the isotropy of the speed of light with respect to an observer in every inertial frame must be abandoned with the assumption of absolute synchronization. No, say it isn't so. All right. We have already shown in some previous paper, citation 3, that a perfectly valid alternative to special theory of relativity can be realized without using a postulate of the isotropy of the light. That remains valid in a preferred inertial frame, considering that time and space inertial transformations ITs deduced by Solari. I'll shout out to your boy Solari. He's always out there offering up a friendly transformation to fix relativity or to get it back on the right track, even though, not really possible. This theory was able to simply explain the Sagnac effect as well as the other experimental evidence of special relativity, but it implies the concept of absolute simultaneity with respect to a preferred isotropic inertial frame and consequently inapplicability of Einstein's clock synchronization procedure. We have also demonstrated in citation 3 that this implies a new understanding of the numerical order change of a system. In this paper, we show that the GPS corrections for the Sagnac effect can be correctly interpreted within a novel theoretical framework and that its inevitable presence further confirms a new vision of physical time previously proposed by us. The Sagnac effect in GPS system. In his original experiment, citation 4, performed in 1913, Sagnac split a light beam in two parts, each traveling along the circumference in each opposite directions. The interference fringes effect had been measured when the two light beams were brought back together. So here we have a closed loop, light beam gets split, continues in opposite directions of one another, and then it gets recombined where it hits a photographic recorder, and it makes you can read the fringe pattern displacement, so you can see how much the waves were out of place. Sagnac observed the interference fringes at different positions and measured their displacement at delta s, overlapping the two figures. The value of delta s was a function of the rotation velocity around the circumference, or equivalently, the light velocity relative to the rotating sensor, dependent on whether the light beam traveled towards or an opposite of the rotation velocity. In particular, the displacement fringes, respectively, the long scroll, boys, respectively occurred on the right or on the left when the rotational velocities was clockwise or anti-clockwise, and the entity of delta s always proportional to the value of the rotational velocity of the and dependent on the wavelength of light. In the GPS system, all the time calculations are performed using a non-rotating Earth center framed or reference frame in which light speed is considered isotropic. In this case, the motion of the receiver due to Earth's rotation around its axis during the time signals of the transmitter receiver to control stations determines a shifting on the location of the GPS receiver during time interval and must be carefully accounted for to ensure the accurate navigation results. In fact, the importance of the corresponding correction can reach even a value of 100 nanoseconds. The interpretation of the Sagnac effect one of the most important facts in physics because of its deep consequences on its foundations. Key question is if it can be considered a purely relativistic effect, so perfectly explainable within the relativity theory, or if it indicates the presence of a new law of nature.
Yeah, the new law of nature is ether, the ether vortex that surrounds the Earth that's causing the effect that they're claiming to be the rotation of the Earth.
That's what I think the new law of nature is, the old ether vortex.
I agree.
I don't know if he mentions the ECI, the Earth-centered inertial frame.
Yeah, it doesn't
But
seem like he does.
he describes it in Word, but doesn't name it like
yeah.
NASA does.
Yeah, he
with the
didn't.
specific. Yeah, go ahead.
Yeah, I was gonna say, yeah, he didn't. I was just thinking back to what he was describing. I was like, yeah, that was the ECI, but he didn't tell anyone.
Yeah, the ECI is a mathematical model which does not agree with reality. If you were in the ECI frame, you would see the stars fixed above you, never rotating every 24 hours, minus 4 minutes. You never would see the moon complete its orbit in a lunar day. It would take 2 weeks, maybe it's 4 weeks. The sun would be up for half of the year. We would have daylight, and the sun would cross the sky 1 degree per day. Is that the world that we observe? Of course not. That's the world that you must be in order to use the GPS theory that is promoted by NASA and Stream. In other words, they're creating a fictitious mathematical model which doesn't agree with what we observe, and saying that's the way, that's the frame of reference for the ground stations. So the frame of reference for the ground stations is the world that we see, where the stars and the sun and the moon all move according to the period that we observe. What they're really doing is saying, if we create an ether counterwind, a counter rotation, so to cancel out the true rotation around the Earth, then you will slow down the stars, the sun, and the moon, so that they creep across the sky. And in that frame of reference, which is canceling out the ether, you can do the calculations because you've eliminated the Sagnac effect. The Sagnac effect is due to the rotating ether around the Earth. That's the Michelson-Gale experiment. You can start right at a high level and say, I can't believe any theory that's based on a fictitious math model like the ECI, the Earth-centered inertial frame.
That seems like a fair request, honestly.
Because that immediately cancels out the Sagnac effect. The Sagnac effect is due to the ether that is causing the rotation of the stars and the moon and so on. So once they do that, eliminate the ether by getting into this fictitious frame, then they can carry out the calculations. And I think Alan mentioned that Paul Marmot pointed out that all of their relativistic corrections are really part of the Sagnac effect. And so if you get rid of the Sagnac effect, then you've basically you can deal with the inertial frame. But now you can't. You can produce an experiment that doesn't agree with reality. You can't conclude, I should say, that the experiment proves anything because it creates a fictitious frame, the ECI, in which we don't exist. It's science fiction. So I think that's, guys, that's the easiest way to deal with the GPS. Instead of digging into, all of the details, how you communicate between ground station and satellites, and what is the time delay on the satellite clocks, and all of this detailed nonsense. It's like starting your arithmetic by assuming that 2 + 2 = 5, and then doing all of your calculations with a false assumption. That's exactly what's happening with the GPS system that's being promoted by mainstream. A false reference frame is being used in order to eliminate the ether, which is causing the time delay between the signals between ground station and satellite and receiver. So that's how I would handle GPS, by cutting it off right at the beginning by saying we refuse to use anything except the reference frame that we observe, where the sun and the moon and the stars all move according to the way we observe them, not in an artificial frame, a mathematically constructed frame, which eliminates the rotation, or almost. It eliminates the rotation of the stars and almost the sun and the moon.
Yeah, I like that line of argumentation. I like where you took it.
Well, then you don't have to dig into the false interpretation of what is an artificial world, a world in which we don't live.
Yeah, I like the cutting it off as early as you can before you diverge into getting out of the lab frame for an argument. Because once you've left the lab frame, it's super hard to get back in. So I think that's probably the best way to do it. So you're saying that they're invoking a stationary frame where they remove the effect, like the ether wind effects, so that they could get their measurements, and then when they transform it to where we live, they have to make all these relativistic corrections, which are literally just correcting for they're just classical velocity corrections essentially between the observers, or with respect to the ether itself in the case of the satellites and their atomic clocks.
Right. The same thing happens in special relativity. You have all of these papers that I read. They're, 20, 30 pages long. And if you just look at the two postulates of relativity, both of them have been proven wrong. Speed of light is not always c. All of the ether experiments show that. Speed of light is c plus the speed of ether, and that's the result of the Sagnac effect, the Wang, Young Wang, and other experiments. So one of the postulates is wrong. The second one, the first one's wrong because in an inertial frame, laws of physics are supposed to be obeyed. Only in the Earth or the lab frame is that true. Only in the lab frame are the laws of physics all obeyed. Newton proved that when he did the bucket experiment. Only in the lab frame, when he was observing the bucket, could he apply the centrifugal force law correctly and predict that the water would creep up the sides. If you're on the bucket and the water is still, you predict that there should be no vortex formed, but there is. And the same goes for any other place in the universe where you use a reference frame that isn't the Earth. You cannot use the laws of physics, only in the Earth frame. So both postulates of special relativity are false experimentally. So why should I go any further and consider any theory that's based on those two postulates? And I know experimentally, the scientific method says if it doesn't test by experiment, then it's wrong. That was one of the biggest claims that Richard Feynman made when he heard all of these different theories. He always said, I go back to the experiment. If it tests wrong, it's wrong. Only if the experiments come out right and nature confirms what the theory predicts, only then will I be, only then will I claim that the theory is true. When you get older, guys, you look for ways and shortcuts to cut off long discussions. Like I
I do
said,
that now.
if you go through papers like I've done, where you plow through pages and pages, and yet if you look at the first pages, there's some disagreement with either logic, like 2 + 2 = 5, or there's some experimental disagreement with what's being claimed. Well, that cuts the argument off at the legs, and there's no point in going on.
But it's
This is
really
one of-
impressive math.
Excuse me?
I said, but it's really impressive math.
Yeah, really
Ooh,
impressive.
Yeah.
Anyway, that's my policy. I don't dig
No, I
down
think
in the details when I know at the top is a false assumption. So
that's perfectly put. And yeah, I think that's the point I was trying to make, right? Is that all it really is at that point is it is just nothing but really impressive math. Which is sad that people would, try to think that says anything about reality.
sometimes math is used as a smokescreen.
Mm.
In fact, what we were talking about a few minutes ago, the confirmation of QED by calculating a certain constant. Over 40 or 50 years, they've been calculating this constant, and they still haven't gotten it right. So, and yet they claim that the theory is correct. It's the most precise theory we have. So, math is a tool that can be used or abused. And unfortunately, today, much of math is abused, at least by mainstream.
Yeah.
Okay.
Well, thank you for that
Why the
insight.
silence?
No, you're good. I was just thinking over
I agreed
future
loudly to my mute button. Sorry.
Yeah, I was thinking over future GPS arguments and how to just cut it off right at the ECI frame.
I was looking at one right now, actually, when I was trying to apply it real time as we were talking about it. Yeah.
Nice. All right, cool. Well, let's continue this one on out. So we got let's see. The key question is if it can be considered a purely relativistic effect, or the Sagnac effect, or if it's a new law of nature. So,
No.
yeah, what's up?
No, it's not a new law of nature. It's ignoring a law of nature, the Sagnac effect, and the underlying ether motion.
Yeah, it's the old law of nature.
Has already been proven. It's been proven for over 100 years. Depending on what experiment you want to consider was the first to prove it, you could consider that Airy's failure showed that the ether was affecting the starlight, pushing it sideways as it came from the star to the telescope. And when was that? That was in the 1870s, something like that.
Yeah, I think 1871.
And Fresnel too.
Yeah, That's right.
I like to say
Water.
that special relativity was kind of debunked before, like way before, because I mean, Airy's failure is a good one, but then also just when Fizeau, showed experimentally that the Fresnel drag was a thing. I mean, that right there, that relativity was debunked before it was conceived. That was, in a paradigm fashion, relativity has been debunked, I would say, by the Fresnel drag, and then again by George S. Sagnac with the Sagnac effect in 1913, and then again in a new paradigm way in 2004 with Ruyang Wang with his experimentation. It's like it gets shattered on a different paradigm level each time, is kind of the way I see it.
Even the Michelson-Morley experiment, which was claimed to be a null experiment. Now, they expected 30 miles per second for the speed of Earth around the sun, and they actually came out with an average of 5. And they claim that that's null, meaning 0. So somehow 5 became 0. That's basically the
Dude, I'm gonna start arguing that. Like, so does null mean 5?
That's some heliocentric math right there.
Apparently it does.
Dude, that's
The other thing that surprised them was that the measurements fluctuated, they oscillated beyond the experimental error. Don't let them tell you that, the Michelson and Morley had a poor interferometer. They couldn't detect the ether at the needed level of precision. No, the interferometer that they were using was perfectly adequate and precise enough to pick out even less than 1 mile per second. No, I'm getting the units wrong. 1 kilometer per second, as opposed to 30 kilometers per second. So it was precise enough. That's not a valid excuse.
Yeah, they'll try everything under the sun to null it up, to follow that Wikipedia tow line.
Think of it, the heliocentric model says that the Earth moves fairly constantly at 30 kilometers per second around the sun, right? So you have 2 claims. Number 1, it's constant. And number 2, it's a value of 30. Michelson-Morley showed that the average was about 5. And it fluctuated in 2 ways. It fluctuated every day, and it fluctuated every year. So we had a Fourier series of at least 2 fluctuations that corresponded to the rotation of the universe, the yearly rotation, and the daily rotation of the sun. Both of those were being detected by the Michelson-Morley experiment. It's done by the American, what is his name? No, not Bradley.
Oh, Dayton Miller.
Yeah, Dayton Miller, right, in 1925. So Michelson-Morley was a ether detection too.
Yeah, no, absolutely. Absolutely.
In fact, if you look at all of the motions in the heavens, if you look at all of the satellites, natural satellites, which is the sun and further out, or all the artificial satellites, which are, let's say they're all within the geostationary radius. The old ones within the geostationary radius, they rotate from west to eastward. Anything above that, like the moon, and anything further out, rotates westward, from east to west. Those motions are produced by 2 conflicting ethers, one which rotates the whole universe, and the second one, which applies only in the solar system, it rotates in the opposite direction and slows down the sun and the moon. That's why the sun and the moon don't rotate at the same speed as the stars, because there's a counterwind, counter ether. So what I'm saying is, if you look just at the heavens, you can see the counter-rotating and rotating ether motions that can be used to confirm that the ether exists and that it affects the motion of the satellites. Okay,
Dude,
that's it.
Okay, so I'm thinking about this in my head, right? So, you know, stellar aberration, how it applies to basically everything, like the solar system, essentially, except for the moon.
Mhm.
So I'm thinking like two ether fields. One field represents the moon, and then the other field represents like the universe, essentially, right? And those would be that motion, right? Because if everything like aberrates with respect to the moon, I feel like the moon is like somehow the more like, you know, that's where the distinction comes from. If all the other ones do the same thing and that one does a different one, then that would be like the representation of the two fields. So like what you kind of just described I was like envisioning like a yin and yang symbol essentially for like the universe and the sun and then the moon.
So you say the moon has no well, it has no lunar aberration, right? It has
Yeah.
no yearly cycle of changing latitude and longitude for a point on the surface.
So in that Syngenis book, Galilean Church was wrong or whatever. It says that everything in the sky, you know, has aberration except for the moon. So I thought that's what I was going off of.
I think that may be because that aberration of the moon is below the threshold of detection, the instruments.
Well, you know how they say like, okay, we got this interferometer set up, so now we're measuring the annual nutation, this wobble, and like these different precession wobbles that they say that the Earth is doing. Couldn't it be that they're just measuring like a periodicity within these two fields, like with varying sensitivity? Like as their sensitivity gets closer or more precise, they're starting to get like a different vibration. You know what I'm saying?
Yeah, if they're using anything except the Earth, the correct reference frame. In other words, they're using a frame in which the Earth is a heliocentric model, then they'll have Earth's precession, the astronomical precession every 26,000 years.
Yep. Yeah, that's exactly this. Yep.
Wobbling of the wobbling of the polar axis. Yeah, all of that will be artificially created because they're using the wrong reference frame.
Yep, dude, that makes. Yeah, I was thinking about that because they have like 4 or 5 different wobbles now on the same axis. Just like you're running out of an axis, bro. You got too many precessions. But like it makes sense if it's just like a more refined periodicity within the field. That's you know that's that the electromagnetic propagation is going through. That or it made sense to me in that way. That's cool. Cool. All right. Oh, so before we move on with the paper, do you have anything on the ether rotation going in the opposite direction in the south?
Well, you should be able to answer that. The satellites in the south, do they rotate eastward or westward when they're below the geostationary radius?
Oh, I have no idea.
Okay. Well, they wrote wherever you are on the Earth, the near Earth satellites, the ones that are within this geostationary radius, they rotate eastward, opposite to the stars and the planets and the sun and everything, which rotate westward. So it doesn't matter whether you're in the northern or southern hemisphere. the ether rotation is as I described.
All right.
You have contrary information, or
Yeah, so it's nothing too substantial, but yeah, I was reading through some A.G. Kelly papers, and he mentions in several of them that there was an experiment done in, let me pull up the date, 1995. Bilger, Hands, and some other, and Stedman. They did basically Michelson, Gale, Pearson in Australia, and Kelly mentions that the readings that they got, that the preferred direction was the opposite of the Michelson, Gale, Pearson one. So I tracked down their paper and I read it and stuff and looked at it, and it didn't, like, nothing jumped out at me that I was like, oh, this means it's in the opposite direction. I didn't know if you had anything like or like knew anything more on that. I think you mentioned it one time.
well, I'm certain that the satellites rotate in the northern southern hemisphere. They rotate eastward if they're below the geostationary limit. Because you see, the geostationary limit is the transition point, right? If you're at that point, the satellite either rotates east or west. It's stationary in the sky. Okay, and that's the boundary, if you want, between eastward and westward moving satellites. Whether it's north or south hemisphere makes no difference. I mean, at the equator, they don't change direction. They change direction at the geostationary radius at the equator. That's the turning point. So if you have written information, send it in an email.
Oh yeah,
I'll
definitely.
take a look at it.
Definitely, yeah. I'll hit you up and send you the particulars on it. Okay, cool.
But that would be astounding if that were true.
Yeah, that's because, dude. Yeah, I was like, I can get some real interesting arguments if I can substantiate this better than some guy saying it a couple of times.
If the satellites suddenly change direction when they cross the equator, that would be very interesting.
Yeah.
And illogical.
Yeah. All right, well, let's get back to the old paper here. All right. Hold on one second. Need some water. All right. So, for all attempts to explain the origins of this effect in the context of the commonly accepted formulation of relativity theory has failed for many reasons. Citation 2. The problem is related to one of the most important postulates of special theory of relativity, namely the isotropy of light velocity with respect to the observer and all the possible inertial frames, and the consequent of Einstein's use of the synchronization procedure. In fact, it has been shown in citation 2 that all attempts to explain the effect by means of special relativity, as well as general relativity, inevitably lead to the negation of the constant light velocity postulate and are incompatible with special theory of relativity itself. One of the most common mistakes of the above attempts to think that the anisotropy of the light velocity in the Sagnac effect is actually due to the rotation of the presence of the non-inertial frame, in which the special relativity is not applicable for definition. Nevertheless, as showed by Hatch in citation 2, studying the GPS system, rotation is only causally involved in the process. Causally.
Causally.
Casually.
Yeah.
Causally.
Causally. I'm blacking out on that. Causally, involved in the process of motion for the receiver during the signal transit time must be accounted for independently of the cause and trajectory of motion, and the path followed by the receiver during the arrival time is irrelevant. The solution to this dilemma, as we'll see, can be obtained by adopting a radically different point of view namely the reformulation of the special theory of relativity without using the postulate of the isotropy of the light velocity, and assuming the existence of a preferred inertial frame in which absolute simultaneity holds. The origins of the Sagnac effect is in fact due to the non-isotropic propagation of light occurring every time an observer or measurement instrument is moving with respect to the unique inertial frame in which light propagation is truly isotropic, i.e., the preferred one defined by the following, by the what was this, the inertial transformation or whatever this guy's thing was. On the other hand, the GPS system is in the GPS system, this conception is actually already applied, since the rate of a satellite and receiver clocks is adjusted not as a function of their relative velocity, but by considering their velocity with respect to a quasi non-inertial rotating center to quasi inertial non-rotating frame centered to Earth, thus de facto as the preferred inertial frame. Oh, so just doing it to the ECI like we were talking about earlier? Taking the old measurements in the old ECI?
Sounds like it.
The inertial transformation and reformulation of the special theory of relativity. It has been shown that it is possible, considering only homogeneity of empty space and time and relativity principle, RP, to build the alternative version of special relativity for the theory of a special without assuming the invariance of the speed of light in a vacuum, thus results in also related to a non-measurability of the velocity of light independently of the conventions concerning the synchronization of distant clocks. This synchronization is then substantially conventional and is not necessarily related to the true properties of the physical reality. Citation 3, as known to Einstein himself in citation 3. The Lorentz transformation, LTs, realize a complete equivalence between an inertial frame S0 initially supposed to be a stationary and in which a one-way velocity light is assumed to be invariant, and all the other frames and all the other infinite possible inertial frame systems S in relative motion, in which the Lorentz transformation leave the one-way velocity of light equal to c in all directions, and this is Einstein's synchronization, that the speed of light is isotropic in all directions. The system S0 then loses its particularity and becomes equivalent to any other inertial system in the universe. Nevertheless, alternative synchronization methods give rise to different space and time transformations of which Lorentz transformations only represent a special case. Among these, the inertial transformations founded by your boy Solari represent the best choice, since they are able to reproduce all experimental evidences of special relativity with their transformation of a preferred frame and a varying speed of light. So if we consider two inertial frames, S0 and S respectively, specified by the space and time coordinates of coordinate system here and coordinate system here, we in motion by the relative velocity v, then the length of the x-axis z, or x0 and x, will be equal, and the inertial transformations are defined by the following equation in equation 1, where beta equals v over c, and c is the invariant one-way velocity of light measured in S0. The inertial transformation implies the definition of absolute synchronization, namely two events taking place in different points in the system S, but at the same time t, big scroll, are considered to be simultaneous also in the system S prime and vice versa. The existence of a preferred inertial frame S0, the latter is called prefer because it is that in which the first synchronization of clocks is made according to the Einstein method, and where the speed of light is isotropic and equal to c. while the moving frame is given by C prime times theta equals C over 1 plus beta cosine theta, where C prime and theta respectively are the speed of light and the polar angle in the system S. The explanation of the Sagnac effect and the necessity of a new picture of time. In the 1980s, the CCDS, the Committee Constitutive, has stated that the rules of internationally accepted to perform clock synchronization between the definitely.
That's the same one that Marmé references.
Yeah, but I like seeing it in multiple places. Like
Mhm.
I tried to find these exact ones for this year, and the one for 1990, I think that Marmé cited, but I couldn't find the specific ones. Anyway,
if you need a popcorn at any chance, too, go ahead.
Popcorn Shane.
Yeah, I don't have the PDF, but I'll read from the screen.
All right, go ahead.
Let's see. You stop at the highlighting thing?
Yep. So it's been internationally accepted to perform the clock synchronization with different locations on Earth, and you're right here.
Cool. There are two options. The first one is to initially adjust time when the clocks are at the same point, then transport one clock very slowly to the destination point. Second option is to use an electromagnetic signal to be transmitted between the two clock locations. In any case, before the comparison between the two time readings, the codified procedure prescribes, as above discussed, the application of the three correction factors: A, the relativistic one proportional to v squared over 2c squared, where v is the speed of clock travel, as indicated by the STR, or B, the gravitational one generated by the Earth gravitational field, as indicated by the general theory of relativity, and proportional to g, alpha h over c squared, where g is parentheses AH is the total acceleration at latitude alpha and altitude h. The last one is a correction proportional to 2sw over c squared, where s is the equatorial projection of the surface delimited by the clock, signal path, and the segments connecting the two positions considered, initial and final position of the clocks, with the Earth center. And the third correction, usually incorrectly ascribed to Earth rotation, cannot be derived, as discussed above, within the commonly accepted framework of the theory of relativity, and represent the consequence of the Sagnac effect that, as we will see, can be correctly interpreted through the IT as the antistropy of light velocity is the rotating Earth frame. In the experiment of Sabore et al., an electromagnetic signal is sent from a city A east to a city B west, placed on the same parallel in figure 2. If the two clocks are synchronized by assuming an isotropic light velocity equal to c, we should write T of A minus T of B equals delta of T of AB equals D of AB over C, where T of A is the starting time and T of B is the time of arrival, and D of AB equals theta R, the geodetic distance between A and B. Nevertheless, the experimental result obtained by Saburi didn't agree with 3, so he was forced to add a correction term at hand in order to give the correct result, and whose form is the same of the proposed by CCDS. This expression can be simply explained in terms of IT. According to IT, the one-way velocity of light in the east-west direction is different from that in the west-east direction, and it is equal, with theta equals 0, to C of EW equals C over 1
Oh, you don't
plus
have to
theta.
read the equations if you don't want to.
Okay.
Yeah, just equation 4, equation 5, etc. I respect your commitment, though.
I was going to power through it, man. Learn my Greek alphabet on the fly like Toby did.
Not. You demonstrate your ineptitude to remember the Greek alphabet from the 7 other times you read papers and had to ask the same question.
Honestly, when I read it, I just skipped those, right? It was super easy. I never even had to pronounce it in my head. I just went, that symbol? And then I kept reading, and I associated it to that symbol when I went back and read it, right?
Mm-hmm. Like, it's just variables at the end of the day, right? Like, I kind of come from computer science background, but yeah.
Yep. So the correction of delta T over AB to be applied to 3 is by means of 4. And the corrected interval of time at arriving at B is, through equation 6, that is positive, being C is greater than C of EW. We can now write 6 as 7, where A equals R squared theta over 2 is the area of the triangle AOB in figure 2. And the origin and the mysterious form of the correction required in GPS system to account for the Sagnac effect is then very simply explained considering the alternative version of STR based on IT. And conclusions. We have seen the occurrence of the Sagnac effect, as confirmed by GPS, implies the light velocity with respect to the Earth is different as a function of the propagation direction, while it results isotropy only when referring to a privileged system, as for example, with a good approximations, a geocentric non-rotating frame. If an observer placed at Earth at a given point could contemporarily send two light signals around the Earth, the first to east, the second to west, they would come back at different times. In this case, the effect cannot be determined by invoking a relative motion between source and receiver, but only to a property of light that propagates with different velocity in different directions. The phenomenon is itself, or is that not? No, the phenomenon is obviously crucial in the synchronization procedures of the GPS control systems, and it must be accounted for. Actually, it is considered, but only as a correction to the wrong calculation based on the isotropic light propagation. But it is conceptually and practically meaningless because it would be sufficient to consider from the beginning the difference in light velocity in order to automatically have correct results, and this is just what the IT do. On the other hand, a further confirmation of this fact is given by the GPS system itself, because after a first synchronization, they automatically, quote, include this correction by giving the right time interval. Since it light itself that transports the information, it's only when we try to calculate time through standard STR based on Lorentz transformations that the calculation result wrong, making it necessary to introduce at hand the Sagnac correction. The first very important consequence of this reasoning is that a correct interpretation of light behavior can be achieved only within a theory based on absolute simultaneity, i.e. that defined with respect to a preferred inertial frame, in which, as occurs in the GPS, the clock rates are adjusted not as a function of the relative velocity, but of the velocity of each of them with respect to the preferred nearly inertial Earth-centered non-rotating inertial frame.
There he is.
The experimental results derived from GPS then give further experimental evidences of the theory of relativity, but also on the meaning of time itself that must be considered as duration, namely as a mathematical parameter giving the numerical order of physical changes. Within this picture, the correct synchronization of two clocks can be achieved only when they are synchronized in a resting special inertial frame and is subsequently used for the synchronization of all other clocks located in the moving inertial frames in the instant when they meet the rest clocks. The method obviously leads to the inequality of different inertial frames, among which the preferred one is that where the first synchronization of clocks takes place. And this conceptual framework could also be invoked to successfully explain another experimental fault of Einstein's theory of relativity related to GPS operation. And that is a question known as noon-midnight problem, related to the absence in the difference between the rate of a clock placed at a given position on Earth's surface at midday and midnight. The solution of this question within the discussed model will be considered in a forthcoming paper. What a G, dude.
Dude, I can't wait to read more about the noon-midnight problem.
Wow, that was a pretty strong closing there. Those last couple paragraphs.
Yeah.
Those last three, yeah.
I was just impressed how I remembered what function of something meant.
Yo, yeah, I'm glad
like,
we finally had you read for once.
It's fun to watch you guys struggle, though, to be honest.
Oh, dude, Ron Hatch, the old scandalous clock.
Definitely steal the sources of the sources.
That's such an intriguing title.
How long is this paper? I don't think it's very long, if I remember correctly.
Oh, you already have it? Nice. Yeah. I dropped it in Discord chat, too.
Ron Hatch. See if we can pull them up real quick. Oh, I typed Han Hatch. It's not his name.
It's only about 7 pages, isn't it?
Let me see.
Yeah, those scandalous clocks.
Oh, there we go.
7-pager.
Guys, I think I'm going to bail out. But I just want to reflect on that last document that was being read. There were certain things that raised flags like inertial frame, non-inertial frame, rotating frame.
Quasi-inertial frame?
Yeah, inertial frame is defined as one in which the laws of physics are valid. So if you ask a mainstreamer, is the Earth an inertial frame? Well, some will say yes, and others will say no. And their confusion is based on the fact that if they're heliocentrists, they consider that the Earth is rotating around the sun, so it's in an accelerated frame, not an inertial frame, that is not at rest and not having the laws of physics valid. Sometimes they ignore that and just say, okay, the Earth is an inertial frame, or it's almost an inertial frame because of its centripetal force is not that great. Well, if we go back to Newton's bucket, where he formally treated the effects of rotation, remember that he found out that if he predicted the motion of the water in the lab frame, he was correct. He saw the water rotating and predicted that there would be a centrifugal force forcing it up. But if you were in the bucket frame, you saw Newton rotating and you're at rest, the water would be at rest, and yet you see the water rise. There's no predicted water force, no force on the water that's predicted if you're in the bucket frame. The bucket frame is just any rotating frame with respect to the Earth. So any place in the universe except the Earth is a non-rotating frame. Yeah, I know, the geostationary satellite, that's an exception. But anything in space is rotating around the Earth, and so can't be an inertial frame. So all of these articles that say, consider an inertial frame, mentally what you should be thinking is talking about the Earth's lab frame. And if they say non-inertial, they're talking about anything that isn't the Earth's lab frame. And that's the way I go through these documents. Back to the first principles of what is an inertial frame. I go back to the experiments that were done like Newton, like Sagnac, like Airy. All of these were key experiments. Michelson-Morley. Most of them were misinterpreted by mainstream, which insists on denying that the ether exists. That's why I'm interested in this group specifically, because if you're focused on ether cosmology or ether in general, then that's definitely a focus that I'm interested in. So I'm going to keep track of what you guys are doing. I'll pop in from once in a while, and I'm going to complete an email that I'm preparing for Alan. But other than that, I appreciate your enthusiasm. One of the benefits of being young is that you have enthusiasm. If you're like me, you're going to lose a lot of that. Lose a lot of that as time goes on.
I'm already almost dead, screaming into the void. Sorry.
Yeah, Bennett's hiker. That's a good example of what's an inertial frame.
Yep.
The hiker on the highway is an inertial frame. The guy in the car, he's not. Laws of physics are obeyed by the hitchhiker, but not by the guy driving the car, because he's accelerating. Anyway, I'll be watching you guys. Go ahead.
Does he have to be accelerating, or can he just be in linear motion?
Then you can't apply F equals ma, right? Because if at constant speed, then it's a question of calculating the energy. What is the energy of the car? Well, it's the mass of the car times the speed squared over 2, right? Kinetic energy. If you're in the car, what is the kinetic energy of the hitchhiker? Well, it's not just the hitchhiker that's moving. If you're in the car, the whole road is moving, right? Underneath you.
Yep.
So the whole Earth, the mass of the Earth times the speed of the car squared divided by 2. That's the total energy. So you see, energy conservation doesn't work even in constant motion. Only if frames are, well, if a frame is at rest with respect to the Earth, then it's the lab frame.
Wonderful. Thank you.
Okay, so yeah, even if the car is moving at constant speed, the energy calculations don't come out correct. The total energy for the car is the mass of the Earth.
Hmm.
The whole Earth is moving under the car.
It's
In the case
inverted.
of the hitchhiker, only the car is moving, not the Earth. The car is moving towards him, and that's the only thing that contributes to the energy. Okay.
Dude,
Fantastic.
thanks a bunch,
Epic.
man. These kinematic and dynamic clips are so important to what we're
Oh,
missing,
yeah,
man. Thank you so much for that
Remember
breakdown.
what I said during that talk? I said there were 3. I repeated it 3 times.
Yep.
Right? Kinematics is measurement. Dynamics is predictions. And that's the difference that you have to use to distinguish between what's being discussed in all of these scientific documents, all these journal articles, all of these blur the distinction between what's being measured and what's being predicted, between kinematics and dynamics. It's another facet of the alpha model, emphasizing the difference between the two.
Yep. Super important.
Okay, I need my beauty sleep.
All right. All right. Good night, man. Thanks for popping in, man. Much appreciated.
Yeah,
Come
thank
back
you so
anytime.
much.
Okay, good luck, guys.
Peace.
Take care about it. So I mean, we're already 2 hours deep. Should we maybe?
Call it a night.
I mean,
Absolutely.
Yeah, we can come back to this another time. If anyone wants, check out Those Scandalous Clocks by Ron Hatch. It's not too hard to find with the old search engine. So yeah, before we close out streams, or anyone have any other thoughts or questions? Or I know I will say for myself, I was also fantastic timing with talking about linearization of the Sagnac effect in that paper and the dynamic equivalence between the circular and linear Sagnac effect. And then that paper that so eloquently went into the relativistic problems of GPS as well. Fantastic time to have Bennett pop in and bring us back to the lab frame.
Right, I wish you could see how much damage we've done with that little bit of ammo since the last time we saw him. But next time we'll elaborate.
All right. Did you already promo, or did you say what we're doing Friday?
Oh no, go ahead.
Okay, yeah. So check us out on Friday for Flat Earth Fridays. We'll be going live at 8 p.m. and then we'll be doing it all again on Tuesday. And I'm not sure what we'll be presenting on Tuesday, but something will get done, I promise. So we'll see you guys on Friday and then Tuesday.
Yeah.
Oh,
Thanks. y'all.
actually, wait, we have one more thing. So at some point during the week, also, Shane, we're going to be doing a Twitter space, and it's going to be like another open AMA session like we did for relativity and interferometry. But this one's going to be regarding the Walter Bislin / Shane's model. So if you have any questions about that, we're going to do a whole overview of it, break it down, do questions, so to help everyone out with it.
Oh yeah.
Cool.
So keep
Sounds
an eye out
great.
for that.